I want to talk about phase changes. There are three main phases of matter that you run into in everyday life, and these are solids, liquids, and gases. And a phase change is just what we call it when we go from one of these to another. So for example, when we go from ice, which is solid water, and melt that and make liquid water. Or when we go from steam, which is gas water, and cool it down to make liquid water. But I don't just want to talk about phase changes in this video. What I really want to do is zoom in on solids and liquids and gases and take a look at what their molecules actually look like and how their molecules change as these compounds move between the different phases of matter. Okay? So, let's imagine that we have this huge magic microscope and that we can magnify things hundreds of trillions of times. Let's take an ice cube, which is solid water, and let's set up our magic microscope and zoom in on it and take a look at what we see. So if we could magnify a piece of ice zillions and zillions of times, this is what we'd see. This isn't a perfect representation of what it would look like, but it's pretty darn close. We'd see all these kind of Mickey Mouse looking things, and what they are is water molecules, or the actual molecules that make up the water. And each molecule has one oxygen atom and two hydrogen atoms. So that's what all these are. Now, there are a few things that I want you to notice about the structure of ice. Look at how all of these water molecules are neatly lined up, and they're very carefully arranged and organized. Okay, that's really important. We always tend to see that in solids. There's something else going on here that I can't show you because I don't have 12 or 16 hands. But if I could, I'd be showing you that each of these water molecules is jiggling around, but jiggling around just a little bit. They're kind of shifting to side, moving around like this, but not much. I like to make an analogy with these phases to people at a concert, okay? And the solid would be like people standing up at a concert before the music starts. They're all standing kind of shoulder to shoulder, pretty tightly packed in there, but they're not really moving much. They might be kind of shifting back and forth, but for the most part, they're pretty neatly arranged, and they're not moving much. Okay, so that's solid. I'm sick of solid now. Let's make liquid. What are we going to do to make liquid? We're going to heat up our ice. And what's going to happen is as the ice gets hotter and hotter, the molecules that make it up are going to start jiggling around more and more. It's going to be like at a concert where they kind of, maybe like the warm-up band starts playing, or they just put some music on the stereo. And people begin to move around and break free of their very rigid structure, okay? So all these guys, again, I can't show it very well, but they're going to start moving around more and more, jiggling around as they get hotter and hotter. The hotter they get, the more they jiggle, until they're moving fast enough that they break out of this really neat structure. And so what's going to happen is the solid ice is going to melt into liquid, and we call this process going from solid to liquid. This is probably not new to you, but we call this melting. And what melting looks like molecularly is these guys are moving fast enough that now they break out of this structure, and they're not so organized, they're not so neatly arranged anymore. They break out of that kind of ice cube shape, and now they make liquid water. And so as you can see, it's more disorganized. And also, I can't show this as well, but these guys are moving around much faster than they were in ice. Liquid is like maybe when the band starts really playing, and so people really start moving around, they start trading places. Some people want to get up close to the stage, other people want to move back. And so similarly, we'd see all these molecules really kind of moving around. They're jiggling, they're kind of swimming around in here and so forth. And that's what a liquid would look like. Okay? Now, let's go from liquid to gas. This is when our concert turns into a mosh pit, okay? We go from liquid to gas, we add more heat. And every time we add more heat, the molecules move faster and faster. So these things, as it approaches a gas, are going to move faster and faster and faster. And this liquid is going to turn into a mosh pit. Okay? So what's going to happen, what I mean by that is that these things are going to be moving so fast that every once in a while, one of them is going to be moving so fast that it's able to jump right out of the liquid. And when it does so, it's going to become a gas. It's going to jump out here into the air. This is like a wild, crazy mosh pit that is moshing so hard and so fast that they can throw people out of the mosh pit and they like fly out into the air and just fly away. So I want you to imagine this liquid getting hotter and hotter as kicking all these molecules out into the air. And as they get kicked out into the air, they fly off and start flying around all over the place, bumping into each other, bumping into the sides of whatever they're in. And now, this guy is like all gas. And as you can see, gas is totally disorganized. Solid was very organized. Liquid was not so organized, but pretty closely packed. Gas, they're all moving around real fast and they're all over the place. If there's nothing holding these gas particles in, holding these water molecules, they're just going to float all over the place. They're just going to fly away. And so the process of going from liquid to gas, which we just saw, is called vaporization. Okay, so now we have all this gas vapor. Let's now go in the other direction. What we want to do now is we want to take this hot gas and we want to slow down these molecules so that they'll come back together. So what we're going to do is we're going to pull heat out of the gas. And when we pull heat out of the gas, it's going to slow down the molecules. And so they're not going to have as much speed to be flying around here anymore. And some of them, maybe we make this container there really cold, so when they hit it, they'll lose energy, they'll get cooler, and then they're going to come back here, and as they hit this cold container, they're going to start moving much more slowly, and the gas is going to become a liquid again. And this movement from gas to liquid we call condensation. So now we've gone from gas to liquid, and these guys are still kind of moving around, but not as much when they were crazy flying around gases. Okay? And so it's like now our mosh pit has settled down, maybe the music's turned down a little bit, and now these guys are just kind of grooving away, and they're not moving as fast. The last thing that I want to do is I want to take this liquid and make it a solid, and we call this the process of freezing. I'm going to suck out more of the heat. I'm going to make it colder and colder, and these guys are going to move slower and slower and slower until what happens is they form a very organized structure, just like they did at the beginning. And it's going to look kind of something like this. And here they are, all really nicely organized and nicely packed, not moving much at all, and just sitting there as a solid. So that's how we go from solid to liquid to gas and back again. And what it's important to keep in mind is when we're going in this direction, from solid to gas, we add heat. We make it hotter and hotter. And as we go from gas down here to solid, we remove heat. We suck out the heat and we make it colder. The hotter it is, the faster these things move. The colder it is, the slower they move. And so by changing the amount of heat that they have, by changing their temperature, we change how fast they're moving.